Hello everyone, in this video I am going to explain the client library of Neutralinojs framework. Neutralinojs framework has two major components. The first component is the framework component, which is written in C++, and on the other hand we have the client library component, which is written in TypeScript. So in the previous video we already studied the framework component, and we went through the code and we understood how everything's are connected to construct the framework component. So in this video we are going to study about Neutralinojs client library. So if you check the GitHub organization, you can see the client library source code in this Neutralinoj.js repository. So if we open this one, there's a link to the documentation, right? So if we click this link, then we will see a list of namespaces. Those namespaces are exposed via the client library to the window scopes. If you are using the browser mode or window mode, you can access these namespaces from the window namespace, just typing window.neutralinoj or just typing neutralinoj. So if you open one namespace, now we can check maybe this neutralinoj.app namespace. You will see a set of functions, right? We have app.exit, we have app.killProcess, and there are several functions. So those things are exposed through this app namespace, right? If you check the client library source code, we can find all the implementation details of each function. In this video we are going to learn how each API function are implemented inside the client library, and how the client library is going to communicate with the Neutralinojs main process in order to perform several native operations, right? So if we call this function, this app.exit from the JavaScript world, then Neutralinojs client library is going to communicate with the Neutralinojs server via a WebSocket connection. Then it is going to send some message. Then it is basically called in this app.exit native method via some JSON protocol. Then via the WebSocket connection, then it is going to perform this app.exit method from the main process. And in this video we are going to look into how the communication mechanism happens between client library and the native process. Basically in overall we are going to learn how the client library works with the native process. Very first I will mention how the build process works in this repository. In other words, how you can generate the Neutralinoj.js JavaScript file using the build tools offered in this project. So if you run npm run build, then you can generate the Neutralinoj.js file. So if this command will generate Neutralinoj.js file inside the disk directory. So after running this command, we can see all generated files inside this directory. We have the definition file and JS map file, and also the Neutralinojs client library. So this is how you can generate the Neutralinoj.js file. So when you are working with the API, so in other words, when you are adding or modifying the Neutralinojs API components, you don't need to just run this one and manually copy this Neutralinoj.js into the sample application of the Neutralinojs framework. So but we offer an easy way to do it. So I think in the previous video also I explained how you can do it. So you can just cd into the Neutralinoj main repository. So if we cd into the Neutralinojs main repository, and if you ls the script directory, there are several scripts, right? So we have a script to generate resources.new file, and we have the release script as well, and we have a script to update the client. So this is the one we are looking for. If you call this one, it will automatically build the Neutralinojs client library, and it will automatically copy this generated client library files into the sample application. So when you are developing the Neutralinojs framework function, then you can easily test those functions within your test application. So that's how the development works. Now we can try to run this script. You can just call this function like this, update client. So if we call this one, it will automatically call this npm build with the development flag. So it will basically trigger a development build. So it won't minify the client library, making it easy to debug. So then finally it will copy this generated client library file into the sample application. Then you can simply run the test application and test your feature. So that's how the development flow works, and how you can generate the Neutralinojs client library. Then now we can start looking into the implementation details. So now I am going to cd into the previous client library directory, which is Neutralinoj.js. Now I am going to explain how this client library works. Very first, if you look into the root level files, we have a readme file and changelog file, like some documentation related files, and also we have package.json. Inside the package.json we define the version here, the version of the client library, and some entry point, and some other details like dependencies, etc. And we also have some other configuration files like tsconfig. Here we define some configuration details for the TypeScript transpiler. The main file here is this build script. So if we open this one, this is basically a kind of JavaScript script to generate the Neutralinojs file into this directory. So this build script is responsible for generating these files. It will instruct this roll up build tool to generate go through all source files and generate these build files. You can notice some important configuration here. Here we are exposing the client library as Neutralino. That's why you can access the client library functions or namespaces using the window.neutralino variable or neutralino variable. So that's how the client library is exposed to the JavaScript window scope. And other source code snippets are basically responsible for generating these TypeScript definitions. So that's about the build file. Now we can start looking into the API and how the communication happens with the native process. Very first, we can start from the Neutralino.init function. So when you are developing Neutralinojs applications, you already know that we need to call the Neutralino.init function in order to bootstrap the application. The Neutralino.init function initiates a WebSocket connection with the native process, allowing you to call the native API. Now we can start looking into the src directory. So this src directory holds all the source code of the client library. We have API implementations and some browser related implementations, and WebSocket connection management file, and also some global definitions for the TypeScript. And before checking the init function, we can also check this index.ts file. This index.ts imports all namespaces here, and it's going to export all namespaces at once to the Neutralino variable. Then in the application you can just access all the namespaces using the Neutralino variable, which is defined in the window scope. Now we can find the Neutralino.init function. If we check the API directory, we have all the API implementation. We have app namespace, depot namespace, and other all namespace are implemented here. And we can also see this init function. This is not a namespace, this is kind of a special function to start the application. So if you check the implementation of init function, it is basically initializing the application only once using some kind of contingent here. If this init function is called for the first time, then it is going to initiate the WebSocket connection, and it is going to do some things related to the development. So this section, this code snippet, is responsible for enabling the auto reload feature. So if this event is triggered from the CLI, then it is going to reload the application by logging something into the console as well. So like you understood here, very first it is going to initialize the WebSocket connection, then it is going to enable the auto reloading feature if the application is launched as the development mode. Then finally it is going to define this NL version global variable using version from the package.json. So we are importing this package JSON file, then we are getting the version, right? Then we are defining this NLC version from this version constant. So if we are releasing a new version, we basically update this version here, then it will automatically update the client library version as well due to this code line. So that's how versioning and also the init function works. Here we do three things. First, initializing the WebSocket connection, then doing something related to the auto reloading, and that's only for the development mode. And after finally we are going to define this nlc version global variable based on version from the package JSON, right? Now we can study about this WebSocket init function. If you expand this ws directory, WebSocket directory, then we can find this websocket.ts file, which implements the WebSocket connection. So here is the init function. Very first it is going to call this init auth function. If you check the implementation of this init auth, we can see that it is basically saving this window.nl token into the nl token key from the session storage. The reason is that we use the one-time token security feature. So the nl token is exposed only once. Then we need to persist it somewhere, so we are persisting the nl token inside the session storage. So this is responsible for storing the nl token in session storage for future use. Then when we are calling the native functions, we are going to use the nl token from the session storage. Now we can check back the init function. First it called this init auth function, then it is going to create a new WebSocket instance using this URL. As you can see, the URL is basically the application hostname, which is a local host, and the port is coming from the window scope, right? You may wonder how this comes, this NL port. So if we request Neutralinoj.js file from the Neutralinoj static file server, the Neutralinoj process automatically attach this global variable. So if you request the Neutralinoj.js file from the static server of the Neutralinoj server, then it is going to send that NL token as well. Maybe I can demonstrate how it is exposed. For that I am going to open the source code of the Neutralinoj framework, which is in Neutralinoj folder. So this is the Neutralinoj framework source code. So if we check the server folder, we can check the router module. Here we have a function to serve static content, right? So this is the function. This function is responsible for serving static web resources. So if we request image or JavaScript file, this will serve the content to the web view or browser. Here we can see special condition, right? Then there's a new request. First it is going to check whether this particular request is Neutralinoj.js. It means that the client library is requested. If the client library is requested, then it is going to send the client library source code with this global variable definition. So if we check the implementation of this get global was function in the settings module. So here is the implementation of this get global was. So this is automatically attaching all required global variables, right? So we are attaching this NL port as well. That's how we get the window.nl port global variable here. Then we have the port here. Then we can establish a connection, right? So at this level we are establishing a new WebSocket connection from the application hostname and the port from the Neutralinoj process. Then after initializing the WebSocket connection, then we are going to do some other things. We are going to attach some events. First we are going to attach some library events. Then we are going to attach some WebSocket related events as well. First we can check about this library event registration function. So this is the implementation of this register library event function. As you already know, we don't need to wrap initial native calls with the ready event because the Neutralinoj client library uses some kind of offline queue. So if the WebSocket connection is not established, but you are calling some native API, then it is going to save those API calls, save those messages in some kind of offline queue. Then it is going to process the offline queue when the Neutralinoj WebSocket connection is established, right? So this function call is responsible for that. It is going to process the offline queue. Then WebSocket connection is established. It is going to call this process queue to process all saved messages in this offline queue. We can quickly check the implementation of process queue function as well. Here we are going to process the saved messages until the queue gets empty, and it is going to call the send message function. We are going to study about the send message function a bit later, but this is responsible for sending a particular message WebSocket message to the Neutralinojs main process. We are going to process this message queue array, then we are going to send all the save messages into the Neutralinojs native process using the send message function, right? Now we can go back to the register library events function. Here we process the offline queue, then it is going to do some extension related things as well. It is basically going to dispatch this extensions ready event if the extensions are already loaded, and that's about the ready event callback. Then if we scroll down a little bit, we can find another event. So this function is responsible for setting up some library events, right? We have this ready library event, then we triggered several actions, then we have this extension client connect library, then we are going to do some actions as well. We have some offline queue for the extensions as well. So if the extension is not loaded but we are going to call the extension, then we are going to save those messages in some kind of offline queue. Then we are going to process those things when the extension is loaded, right? So this code section is responsible for that. If the extension is loaded, then we have some messages related to that specific extension saved in the offline queue. Then we are going to process those messages using this process queue function, right? So that's about the register library event function. It is basically going to set up some library events and actions. Then we can check the other function. After calling this register library events, we are going to call this register socket event function. So this function is responsible for setting up some WebSocket related callbacks. So we initiated the WebSocket connection here, but we didn't set up some callbacks, right? We didn't set up some message callback or on connect callback. Those things are not added yet, so we use this function to set up those actions. So for example, when the WebSocket connection is established, what we need to do. So if the WebSocket server sends messages, then what we need to do, like those actions are implemented in this WebSocket events function. So now we can check this register socket event function. So it is going to attach several event handlers. We have message event handler and open event handler, and also finally we have close event handler. We can check first this message event handler. So this event handler will be called when the WebSocket server sends some message. The WebSocket server typically sends two message types. The first thing is that, so if the client library calls some native event, then it is going to respond that particular native event, right? Then we have some native callbacks and we have some events as well. So those things are processed here. If the particular WebSocket message contains some kind of native callback, then we are going to resolve or reject the promise based on the payload. So we extracted the message into this message variable. Then we are checking whether this message contains some kind of native callback. We use this ID to check whether that particular message is a native callback. So if it is a native callback, then we are going to resolve or reject the promises. Otherwise, if this message contains some kind of event, then we are going to dispatch the event using this events dispatcher, right? So that's about the message handler. Then we have some other handlers as well. We have the open handler. This open event handler will be called when the WebSocket connection has been established, right? Then we are going to dispatch this ready event. This is a library event that indicates the WebSocket connection has been established. And finally we have the closed event handler. This closed event handler will happen if the WebSocket connection was disconnected. So if the WebSocket connection has been disconnected, we cannot call the native process using the WebSocket connection. Then we trigger this server offline library event, right? Then using this error payload. Now we can study about the API implementations, and now we can check how each API function is going to call the native process and how the native process is going to send some data back to the client library. To explain the API implementation of Neutralinojs client library, now I am going to execute the test application. Currently I changed the directory into the Neutralinojs main repository. Now I am going to run the test application. So using this command, now I can run the test application. I am going to load the resources from the directory using this load DRS option. Now the application is loaded. To explain the API implementation, now I am going to trigger some native functions here. Now I am going to trigger Neutralino app app.getConfig function. So if we trigger this function with the await keyword, we can see the configuration, application configuration. So we have the application configuration here. Now we are going to study how this function is called in the native process and bring native response to the JavaScript world, right? Very first we can check the source code of the app.getConfig function. So if we open app.ts, we have all functions related to the application namespace, and we have getConfig function as well. So it is exported from the client library source code, and this is of course an asynchronous function. That's why we use await, and we also can use the promise based functions as well, like then, catch, likewise. So we use this await keyword and we call this function, right? So when the getConfig function is triggered, we are going to call this send message function, right? As the parameter, we are going to send this native method identifier as well, which is app.getConfig, right? So using this particular key, the native process is going to identify which native function is called, right? So this app.getConfig doesn't accept any kind of arguments, but if you need to send some kind of arguments like this, so if we check the broadcast function, we need to send the event and also some data object. Then we can use the second parameter to send those required arguments. So if we check the getConfig again, when the getConfig function is called, we are going to call the send message function using the app.getConfig native method identifier, right? Then if we check the send message implementation, so this is coming from the WebSocket module. So if we check the implementation of send message function, we can see, so it accepts the native method identifier as the first argument. Then it is going to accept some optional object as well. So if we need to send some parameters, then we can use this second parameter. Since the send message function is also asynchronous, we wrap the implementation with the promise and return the promise from the function. So we can use await or then, catch features from the JavaScript so to invoke this one. Now we can check how this function works for the app.getConfig method. So we have app.getConfig as the method variable. So very first we are going to check whether the WebSocket connection is established or not. So if the WebSocket connection is not established, then we cannot send a message right now, because there's no WebSocket connection established, right? So we are going to save those messages in the offline queue that I mentioned before. So we have the offline queue here. This is basically a normal array. So we are going to store those messages inside the offline queue, right? Using this function, we can check the function implementation. If we check the function, it is basically going to push the particular message into the offline queue, right? Basically saving the message inside this offline queue array. Then we are just going to exit from the callback because these messages are processed later, right? Assume that now the WebSocket connection has been established, right? Now we are not going to store those messages inside this offline queue, but we are going to continue execution, right? Now we have the app.getConfig as the method. Next we are going to generate some unique string using this function. This function generates some unique string based on this UUID implementation. It will basically generate UUID v4 random string, and so it is going to return the particular randomly generated value into this ID constant. Now we have some unique identifier to identify this particular message, right? Next we are going to fetch the access token value into this access token constant, right? Now we have the access token stored in the session storage, right? If we check the implementation of this getAuth token function, we can see it is taking the NL token from the session storage, right? If however, if that NL token is already defined in this window scope, it is going to fetch NL token from there, right? Now we have enough data to communicate with the Neutralinojs main process, right? Now we have all data to create a native message, right? The native message format has 4 keys. We have ID, method, data and token. Now we already generated the ID and we have the method name, which is app.getConfig. For the data key we don't have anything because the app.getConfig function doesn't accept any kind of parameters, right? We have the access token inside this access token constant. Now we can send the particular message into the Neutralinojs backend, right? So before sending the message to the server, now we are storing this resolve and reject callback inside this native calls map. The reason is that if the Neutralinojs server send a reply for this particular message, then we need to call the resolve and reject immediately, right? So if we store this resolve and reject based on the ID, then we can easily call resolve and reject for a particular native API call based on the ID provided from the Neutralinojs server, right? To understand this context further, now we can see how the Neutralinojs client is going to send the particular message into the Neutralinojs server using the WebSocket connection. Now I am going to call the app.getConfig function again, and I am going to check the WebSocket connection also, right? So the client library sent this message, right? So if we check the code, we generated a unique ID, then we took the access token from this session storage, and we sent the message, right, with the method name and also with the parameters. So if we check the message here, we have ID, the auto generated string, and we have the method name app.getConfig, access token as well. And in this scenario, the data is null, right? The reason is that we don't have any parameters for the app.getConfig, but now we can call a function with parameters to understand this further. Now we can maybe call window.setTitle, which accepts one parameter. Yeah, I'm going to change the title. Now we can check the title, the current title. So current title is test app. Now I am going to change the title into test. So the title is changed, right? So in the same time, if we check the WebSocket connection, now we can see these messages, right? So the client library sent this message. So we have the auto generated ID, then the method name, and we have data as well. So inside the data object, we have title is test, right? So likewise, the Neutralinojs client is going to send more parameters using this data object, right? So if there are more parameters, then it is going to send those parameters inside the data object, right? So like if we have another key like maybe content, we are going to send title test and comma the content and the content value, right? And finally we have the access token as well. So when the Neutralinojs client sent this one, so we already store the resolve and reject inside this native calls map, right? So if we check up, we can see the native calls map. So it is going to save resolve and reject things based on the ID, right? So when we call this window.setTitle, then so it is going to update native calls map with the resolve and reject of the this context based on the ID, right? So at this level we have this ID inside native calls map, right? Then we have resolve reject callbacks as well. So if we quickly check the Neutralinojs framework source code, we have the Neutralinojs server implementation here. In the previous video, I already explained this handle message function. So this is responsible for replying a particular native call, right? So assume that we have window.setTitle call coming from the client. So now we have ID, method, access token, and those things according to that particular call, right? The method is of course window.setTitle. Now the framework is going to execute that particular native call. Then it is going to get the response into this variable. Now it is going to send the native response into the client back, right, using this server send function. So importantly, we are going to use the same ID, right? Then we have the same ID when we are receiving the message from the WebSocket, right? We can check the message handler now. So if we check the message handler, now we are receiving the message. So at this level, it identifies this particular message coming from the Neutralinojs server as a native callback because we have the ID in the response, right? Here we are going to call the resolve function to resolve the promise based on the message ID, right? In this case, the message IDs are identical. Now at this level, we resolve the promise created from the send message, right? So using that approach, this particular message coming from the native process resolve the promise, right? Because the IDs are identical. So all native functions are implemented using this approach. All native functions call this send message to communicate with the Neutralinojs main process, and the client library resolves promises using the message handler, right? You can see the message handler implementation here. Here it is going to resolve or reject promises that are created in the send message function, right? So we are going to create a promise here, and it is going to store the resolve and reject callbacks in some kind of map based on the ID. Then it is going to call the resolve or reject callbacks based on the ID here, right? That's how the whole communication works. So if we check other native functions like maybe debug, we can see the same function call is used. We are going to convert this particular method call into a WebSocket message using this send message function, right? All things are implemented using that approach. We can see the file system functions as well. In the create directory also we use send message and this native message identifier. So all things are implemented using that approach. But there are some client side implementations as well. For example, if we check the window create function, so this is the window create function. So most of the implementation belongs to the client side. The reason is that window.create function creates a new window using a new process, right? New Neutralinojs process. So here the most of the code responsible for is spawning a new Neutralinojs process based on the arguments, right? Here we can see we are constructing the CLI argument for the new Neutralinojs process. Then we are going to use Neutralinojs.exec command function to spawn a new process. Similarly, some other modules like storage, those things are also going to use the send message function directly, right? Those things are not going to do some client side implementations, but functions like window create and also set druggable region and those kind of functions are using some kind of client side implementation, right? But those functions are finally going to call Neutralinojs process as well, but there are some client side code as well. In other words, there are two types of functions, right? We have functions that directly call the Neutralinojs native API using the send message function, and there are some functions that does some processing from the client side and finally communicates with the Neutralinojs server, right? Finally, we can check the browser directory. Inside the browser directory, we have event.ts file, which is responsible for handling Neutralinojs native events. So we can register events using on function call. We can register some predefined native events like ready, tray menu item click, like those things can be registered, and also you can register any custom event as well using this on function. And we can also unregister events using the off function, events off function, and we can dispatch events using events dispatch function, right? So these browser related event functions are exposed from the event.ts API implementation, right? Here we expose all browser related event functions. In this video we went through the Neutralinojs client library implementation, and we studied about Neutralinojs client server connectivity, and we checked the WebSocket based communication mechanism as well. I think if you are willing to contribute Neutralinojs client library, now you have a better idea, because in this video we went through all the internal parts, and now you can easily contribute this project. In next video I am planning to explain Neutralinojs CLI implementation. So I am going to explain how new create, new run, those commands are working internally. So if you are planning to contribute the Neutralinojs CLI project, then the next video will help you. So see you in next video.